In this video, we're going to spend some time reviewing some of the pre-calc material, and some of it's even really college algebra, that's a big part of calculus. Often when we learn the new calculus material, the new material is easy, but recalling all of the techniques and concepts you've learned in earlier courses is kind of hard to recall. In essence, you're going to have to know everything you learned in college algebra and pre-calc all at once. So, early on, it's going to take some time trying to get used to the old techniques and old skills you used to have and try to remember how to pull them back and how to try to keep them close so that they don't get pushed quite so far back in the memory as time moves on. One of the things you're going to do a fair amount of in calculus is use lines. And you're going to be finding equations of lines. Lines are going to have an important relationship to one of the major tools of calculus, the derivative. But that's for another time. Right now I just want to sort of talk about how we would find equations of lines. Now I think when most people think about equation of a line, I think what usually comes to mind is y equals mx plus b. This is an easy formula to remember. It gets used a lot, and it's fairly easy to work with. But there's another formula that may be just as useful, and maybe even more so. It's the y minus y1 equals m times x minus x1. Now y equals mx plus b is called the slope-intercept form because you have a slope and an intercept. And this second version of the equation of a line is called the point-slope form because you have a point, x1 comma y1, and a slope m. And since that's what we have here, a slope and a point, it would be easier if we know this formula to use this version of the formula. That's a big if for some students, and it's a little bit harder to memorize. But if you think about your slope formula is really y2 minus y1 over x2 minus x1. If you think about multiplying this up to the other side, right, that's really what you have over here. M times x instead of x2, just x, and instead of y2, just y. So if you can remember your slope formula, it's actually not that hard to get this one back. And if I look at the information I have here, a slope of 2/9, a point x1 comma y1 of 2 comma 7, then this version of the formula simply becomes y minus 7 equals 2/9 x minus 2. And this is perfectly fine as an answer to this question. Find the equation of a line, here it is. Now, if you had to put it into a graphing calculator or Desmos or something to take a look at it, then you would want to maybe add 7 to both sides, distribute the 2/9 and combine like terms, and then your answer would look a little bit more compact like this. Okay? But, I find it easiest if I just have a point and a slope, which is what the situation in calculus will often be, to just use this version of the equation of a line. Now, if you did want to use the other version, then you still have the same information. You have an m, an x, and a y, but they're going to go in different places. So you're going to put the 2/9 in here, you're going to put the x equals 2 in here, and you're going to put the y equals 7 in here. And then you have to actually solve for b. Okay? So, the advantage of the other formula is that you don't have to solve anything. You're just literally plugging things in, rewriting it, right? Done. In this one, you have to solve for b, which is certainly something you can do. It's not very complicated, but it does take a little bit more work. So if you did 7 equals 2/9 times 2 plus b, right now you have 7 equals 4/9 plus b. You're going to have to subtract 4/9 and subtract 4/9. Now, I like to think of 7, right, in terms of 9ths. It's 63/9. So 63 minus 4 is going to be 59/9. That equals b. And then you always have to rewrite, the equation of the line, right? Y equals 2/9 x plus 59/9. And what you would see is if you actually took the time to simplify and solve this other version for y, you would have the same answer. So, this is an or situation. Either way would work. But, if all you need to do is write the equation of the line, you might want to work on this point-slope form. Okay, so we're going to do a few things in this video. We're also going to look at another sort of really familiar, important concept of solving quadratic equations. We're going to solve plenty of equations in calculus. Some of them will be algebraic, polynomial, linear. Some of them will be trig, exponential, and so on, and we'll tackle those at another point. But quadratic equations, right, if you remember, they have an x squared, and this is sort of the closest one to a quadratic equation. We learned really three techniques. We learned factoring, right? We learned the square root method, right? And you can use completing the square as sort of a fourth option to do the square root method, or we use the quadratic formula. And the quadratic formula is the only one of these that always works. Now, technically, completing the square always works, but it can get really tedious and computationally a little difficult. So, we tend to sort of look at these three techniques. Factoring, right, only works under certain cases. You have to find two numbers that multiply to one thing and add to another, and then set up the parentheses. The square root method has to fit a certain pattern, and if you look at part A, you basically have something being squared equals a number, right? So the square root method is going to work just fine here. Okay? If you're going to use factoring or the quadratic formula, you're going to have everything equal to 0. Okay? So I'm going to take a look at this third one over here, and I'm going to move this 7 over, right, to make 3t squared minus 5t minus 7 equals 0. And if this one is going to factor, which is what I always try to do first, I'm going to have to find two numbers, right, that multiply to negative 21, and those same two numbers are going to have to add to negative 5. Okay? Now, the only options for multiplying to negative 21, which is always where you want to start, right, the multiplication is either 1 times 21 or 3 times 7, right? And neither of those pairs are going to multiply to to negative 5. So factoring is not going to work here, right? But it's always worth giving it a shot, and in this case it just didn't work out. So I'm going to have to use the quadratic formula here, right? And the quadratic formula, if you have forgotten, right, is negative b plus or minus the square root of b squared minus 4ac all over 2a. Okay? Now, sort of started at parts A and part C, and you might be wondering why a log equation in part B is sort of mixed in here. And the reason is, if you remember your log properties, when you add two logs, right, you're really getting the product, right, of the insides. So when we do a product here, and I'm going to just move my notes here about the different factoring techniques out of the way so we have more space. Okay? If you multiply the insides, you're going to have x times x minus 3 equals 1. When you do log expressions, if you don't see a base, you assume the base is 10. And when you want to solve a log equation, you always rewrite it base to the power 1 equals what's on the inside. Okay? So here you get 10 equals x squared minus 3x. I'm going to subtract the 10 over. I'm going to turn it around so that everything is on the left-hand side. And this one actually does factor nicely, right? Because two numbers that multiply to 10, like 2 and 5, also subtract to 3. So this one, because there's no number in front of the x, okay, you can just drop the negative 5 and the positive 2 in. Right? These two multiply to 10, right? But they also add to negative 3. I'm sorry, they multiply to negative 10, right? Now, if there was a number in front of this x squared, it's a little more complicated because remember the inside terms come from here, and if you start putting numbers in front of the x's, you have to account for them. So factoring can be a little bit complicated, but it's going to be a very important skill, right? And then you solve this by solving each of these two expressions separately, and you get these two answers. Okay? Now you have to be a little bit careful with logarithms because logs have a domain restriction. We'll talk about that more a little bit later, the idea of domain. But logs cannot take in negative numbers, and if you try to put negative 2 in here, right, then you have a problem. Okay? So putting a negative 2 in here is going to cause a problem, which means it's not an actual valid answer. Okay? Now, if you put a 5 in here, it will work. Right? You'd have to do the check to do that, but it turns out there's only one answer here. Okay? So that was a little bit more complicated, but I did want to show you and really focus on the factoring part of this here. This first example, which I had skipped over, right, the x minus 3 squared equals 5, we know that if x squared equals a number d, then x can be the plus or minus square root of that number d. Right? We call this the square root method. It's sometimes called the square root property. Now in this case, it's not just x, right? It's x minus 3, and over here the d is 5. So what we get is we get x minus 3 is plus or minus the square root of 5. Okay? Now technically I don't really need the parentheses here, right? And it's always better though to put them in and then realize you don't need them than the other way around. And now you have to solve for x, but it's not that hard to do. Just add 3 to both sides and try to remember that square root of 5s can only be added with other square roots of 5. So these are considered not to be like terms, so you have to keep them separated. Okay? You can't put the 3 and the 5 together and call that the square root of 8. It's a tempting thing to do. It's a common thing to do, but it just is not valid. Okay? Now your other option here, if you don't remember or feel comfortable with the square root method, is to multiply this out. Think of this as x minus 3 times x minus 3. FOIL, distribute, bring the 5 over, use the quadratic formula, and it's going to take you a while to get there, but you still would. Okay? The quadratic formula, you remember, in a case like part C over here, right, the A, B, and C are the coefficients of the terms, quadratic linear constant. Now in this case we have t instead of x, right? But otherwise it's perfectly fine. And the best thing is to just drop everything in. I like to use parentheses as placeholders so that minus signs don't disappear or get used improperly. So you can always start by filling the parentheses in and then deciding later you don't need them. Okay, so every A gets filled in with 3, the B's get filled in with -5s, and the C gets filled in with -7. Okay, now at this point it's really just arithmetic and some simplifying. And for some people that's easy. For some people they tend to get lost. You're going to have to decide if you want to write more out. Some people like to write everything out. Takes up a lot of space, takes some time, sometimes wears you down. But it helps you keep everything organized. Some people like to do a lot of things in their head, and for some people that works out great, and sometimes it lends itself to mistakes. So I think a good compromise, instead of copying the whole thing over, is I like to look at this part inside the square root. Now it has a formal name, it's called the discriminant, but it doesn't matter if you call it that. But I like to just do that work up here, keep it isolated, put it together so I don't have to copy the whole thing over. But I notice that negative 5 squared is 25. I see a minus and a minus here. I know that's going to be a plus. And 4 times 3 times 7, I'll do the 3 times 7 is 21. 21 times 4, right, is going to be 84. And then I can come on this line and say, okay, well, negative 5 is 5, plus or minus the square root of 109 over 6. Okay? Now, this is the final answer. But you would always have to consider whether or not a square root of 109 could be broken down and has any perfect square factors. In this case it doesn't. I think 109 is a prime number, but I'll have to double check on that. But it can't be broken down, and to be honest, it wouldn't be the worst thing in the world if you didn't simplify a square root. It's probably better that this is a little bit more than 10, because the square root of 100 is 10, and so on. But it's most important that you know how to use the quadratic formula and get to this point. Okay, so we're going to stop here in this video with some basic, really common skills that you'll use a lot, lines and quadratics, and then we'll look at a few other things as we move on.